For example 5, the approximation natural log of 1 plus x is approximately x minus x squared over 2 is used when x is really small, okay? So we want to use the Lagrange form of the remainder, okay, to get a bound for the maximum error when the absolute value of x is less than or equal to 0.1, okay? So what this is saying again is that the x's that we're going to put in to use to approximate this can have to be between negative 0.1 and so negative 0.1 is less than or equal to x, which is less than or equal to 0.1. Okay, so our function is going to be the natural log of 1 plus x. Okay, so this is the approximation, all right? So that, since it's second degree right here, okay, that means it's the second order Taylor polynomial, okay? So we're going to go p, we're going to write p sub 2 of x is equal to x minus x squared over 2. All right, and then to get this error, right, the maximum error, the error, or maximum error bound, okay, the error is equal to the absolute value of r sub 2 of x. All right, and then we know from the Taylor theorem that that's equivalent to the absolute value of the n plus 1 derivative, so that'd be f triple prime at c over 3 factorial times x cubed. All right. Okay, so now we got to figure out what the third derivative is. Okay, so we have f of x is equal to the natural log of 1 plus x. So f prime of x would equal 1 over that, right? Remember, derivatives of natural log, 1 over 1 plus x times the derivative inside, which would just be 1, okay? So now this would be 1 plus x to the negative 1, all right? That's going to be easier to take the derivative when we rewrite it as a power, okay? So then we need the third derivative, right? So the second derivative of x would be negative 1 times 1 plus x, subtract 1 from the power, so that'd be negative 2, and then times the inside, derivative of the inside, which would be 1 again, okay? And then f triple prime of x is equal to, so that'd be negative 1 times negative 2, so that'd be 2 times 1 plus x raised to the negative 3 times the derivative of 1 plus x, which would be 1. Okay, now we want to take a look at this and go, okay, so this is equivalent to 2 over 1 plus x. And let me slide that up. Sorry, guys. 2 over 1 plus x cubed. All right. So we put c in here, right? Okay, so this is equivalent to the absolute value of 2 over, in parentheses, 1 plus c cubed over 3 factorial, and then times, and I'm going to put the x cubed up here at the top, times x cubed. All right. All right, so the next thing that we're going to need to do is we're going to need to find, okay, we want to get the maximum value of this, and what c value, okay, will cause, or not necessarily c value, but what value will cause this to be the maximum. Now we're only going to look between 0.1 and 0.1, negative 0.1 and 0.1. That's where we're going to look to see where this is going to be a maximum, okay? So what we're going to use in this case to find the maximum is a graphing calculator, okay? And we're going to look at the graph of 2 over 1 plus x, the quantity 1 plus x cubed. Okay, so I'm going to go to my graphing calculator now. All right, so with my graphing calculator, I'm going to go press the window button, and then I'm going to change this to negative 0.1 for my x min, and then my x max is going to be 0.1. And then my x scaling would do 0.01. It really doesn't matter what your x scale is. Your y min, we're going to do, let's do -3. And your y max, let's go 3. And y scale, let's do 1. All right, so then we're going to put in for y equals, let's clear all of these entries out. And I'm going to come up here to y1. Okay, and y1 is the third derivative from our paper, and it's 2 over, and then 1 plus x quantity cubed. Okay, and we're going to graph and take a look at this. We may have to adjust, we don't want to adjust the y min or the y max, or I'm sorry, the x min or the x max, because those are set because that's where we're saying we're looking for these x's, okay? It's the y mins. We may need to adjust to see the graph, so I'm just kind of randomly guessed -3 to 3. So let's take a look at the graph. Okay, so this is the graph of y equals 2 over 1 plus x cubed, the quantity 1 plus x cubed. All right, so if you look at this, it's decreasing, right? So where is this going to have the maximum value at? Well, it's going to happen right here. Well, what is that x value that's happening at? Well, that's going to happen at -0.1, because I know this side of the screen is -0.1, okay? If it was going up and coming back down, then we'd have to find where that is, okay, that x value, okay? And then we could put that in, and then we would know our error is going to be less than the maximum of that, okay? All right, so we know what's happening at x equals -0.1. You could even trace it and put in -0.1. Okay, and see it's 2.74, right? And as we go down, see how it's getting smaller and smaller and smaller and smaller and smaller? So that's going to be the maximum right there at -0.1. Okay. Okay, so back to our paper now. All right, we know, okay, so what we did with the graphing calculator, I'm going to write a little note here. What we did is we used the graph and to find the maximum value of this, right? Use graph to find maximum of 2 over 1 plus x cubed, okay? And that happened at x is equal to -0.1. That's where that happened at, okay, from the graphing calculator. Okay, so that means that this error, right, must be less than or equal to the absolute value of 2 over 1, and that value right here is -0.1. So plus a -0.1, or I'm going to go ahead and write plus -0.1 cubed over 3 factorial times, I'm going to put the x cubed back out here. Okay, so 1 plus -0.1, so that'd be 0.9. So I know my error is less than or equal to the absolute value of 2 over 0.9 cubed all over 3 factorial times x cubed. All right, now I'm going to break the absolute values up now. So that would mean the absolute value of r sub 2 of x is less than or equal to, now this is 2 is going to be positive, 0.9 cubed is going to be positive, so this is going to be positive. So we really don't need the absolute values for that, or the 3 factorial, right? And this becomes 2 over 0.9 cubed, you wouldn't have to have the parentheses, times 3 factorial times the x cubed, right? Okay. Or not times x cubed, I'm sorry, times the absolute value of x cubed. Okay. Now, this absolute value of x from up above right here, the absolute value of x has to be less than or equal to 0.1. Okay. So then that would mean the absolute value of r sub 2 of x is less than or equal to 2 times the absolute value of x cubed over 0.9 cubed. 3 factorial, that'd be 6. So times 6. And then times this absolute value of x cubed. But then this, all the absolute value of x's has to be less than 0.1. You know, I accidentally put absolute value of x twice. Didn't mean to do that. So let's erase this one, okay? All right, so what I'm trying to say here is that then this is less than or equal to 2 times 0.1 cubed, because the absolute value of x has to be less than 0.1 over 0.9 cubed times 6, okay? So I'm gonna put this into my calculator. And so my error bound has to be, okay, and I'm gonna go back to my graphing calculator and I'm gonna put this calculation in. All right, so on my calculator, I'm gonna type in, the calculation I'm gonna do is alpha x to get the fraction bar, and then 2, and then times 0.1 raised to the third power, and then 0.9 raised to the third power, and then times 3 factorial, which is 6, so times 6, and press enter, and we get 4.5724, okay? So that's what we're gonna record on our paper. All right, back on my paper, I'm gonna write the error band has to be less than or equal to 4.5725. I'm just gonna round to 4 decimal places, times 10 to the negative 4th power, okay? So that's a pretty small error because you would move the decimal 4 places to the left, right? Okay, and that's how you get the maximum error, okay, on this when x is between negative 0.1 and 0.1 for the natural log of 1 plus x, and we use a second order Taylor polynomial, our error will be less than this number right here. All right, and that's what that's telling us. Okay, and so what was different about this problem? Okay, so what we had to do is we had to use the graph to find the maximum of the third derivative. Okay, so on the interval negative 0.1 to 0.1, let's find the maximum there. Okay, and it happened at x equals negative 0.1. It happened on that left side. Okay, all right, so then that's really it for the main ideas for this lesson. Okay, so the next two things I want to look at is getting you ready for some questions similar to this that they've asked on previous AP exams. Okay, so that's the next thing. Okay, you could go and do the homework right now if you wanted to. Okay, so again, just pause. Okay, after every example, just take a pause and just take a break and just digest all this information that's coming at you. Okay, all right.